The 28th problem for this first ACT practice test focuses on quadratic equations and their solutions. So the equation y is equal to ax squared plus bx plus c is graphed in the standard xy coordinate plane below for real values of a, b, and c. When y is equal to 0, which of the following best describes the solutions for x? So we have this quadratic equation, which is written in general terms, and we're setting y equal to 0. Or in other words, we're solving this quadratic. And when we set y is equal to 0, that is all values of this curve on the x-axis. So wherever this curve here, this parabola, crosses the x-axis, that's essentially what we're trying to find. So these two values here, we have to determine if they're distinct, if they're positive, negative, if they're real, or if they're non-real, or in other words, complex. So to truly understand a problem like this, it's best to look at each of these scenarios so you can see what they all look like. So let me draw graphs for each of these cases, and then we'll go back to this original problem. So now that I've drawn each of these graphs out for each of the cases, we can actually analyze them. So there's choice F here, two distinct positive real solutions. So the word distinct just means that they're not the same value. And then the word real just means that they don't have any complex components, or they essentially don't contain I, the square root of -1. So real solutions do not have imaginary parts. So the question is, which of these graphs here have two distinct solutions that are real and positive? And you can see that this choice here is letter F, since the solutions where the curve crosses the x-axis, these are both positive values since it's on the right of the y-axis, and they're both real numbers, and they also are distinct since they're not the same value. So this is choice F, and then G is two distinct negative real solutions. So you can see that that would be this case right here, since we have two real solutions that are distinct, and they're both on the left side of the y-axis, making them negative. So this right here is choice G. And for now, I'll skip choice H, since you might already see which graph that is. And choice J here, two real solutions that are not distinct. So by not distinct, that just means that the solutions are the exact same value. So in other words, choice J really only has one value where it crosses the axis, or where it touches the x-axis. And that would be this case right here. So if you have two real solutions that are not distinct, like let's say this is -1 as our solution, then that value, -1, is just the solution twice, which might seem strange, but we call this a double root, or a double solution. So this right here is choice J. When you have a double root, it just means that the parabola will just touch the x-axis. And it could also look like this. But basically, just as long as it's only touching and not going through. And for choice K, two distinct solutions that are not real. So not real being the key words here. And what that means is that our parabola never actually crosses the x-axis. So if you have graphs like this, where notice it never actually goes through this x-axis here, what that means is that if you actually solve the quadratic equation and solve for which values of x, where y is equal to 0, what you end up with is imaginary solutions, or complex solutions containing I, the square root of -1. So you'd still end up with two distinct solutions, but they would contain I in them. So this right here is choice letter K. And I left out H because H is our answer for this problem. Since notice, we have two distinct solutions since they're not the same solution, and one is positive and one is negative. So choice letter H is our final answer.